What's going on, guys? So welcome to another session of Ceerazzledazzle Physics. It's been a while since I made a video, but here it is. We're back in it. I've finally sorted myself out and finally I can get to making good content to help you with your studies. Okay, so this lesson's all about the electron volt. So put down today's title, it's going to be the electron volt. Okay, so let's get straight into it. So this is A-level physics or maybe high school physics for some of you, but yeah, it's all the same thing. So what exactly is the electron volt? Let's discuss it in this video. The electron volt is an alternative unit of energy. So we all know what energy is, and hopefully we recognize that energy is measured in joules. So look, as you can see, I'll put it down over here. Energy is usually measured in joules over here. We use it when looking at very small values of energy. So rather than actually using joules, we can actually use electron volts over here. It is equal to the energy gained by an electron as it moves through a 1 volt potential difference. So it's equal to the energy gained by an electron as it moves through a 1 volt potential difference. Right, so that bit over there, it's a bit difficult, so I'm going to explain that later on in the video. But as you can see, as a starting point, I've got joules, that's a unit of energy, calories, don't forget food, kilocalories, and look, kilowatt hour over here. All of these are going to be units of energy. Even the kilowatt hour, because don't forget that's kilowatt, that's power times by hour, which is time, power times by time, so that's a unit of energy here. But in this lesson, we're going to be talking about electron volts, which we use in physics. And that's when we're dealing with very small values of energy. So how much is 1 electron volt? Well, the symbol of it is going to be the following. So over here, you can see that we've got 1eV. That stands for 1 electron volt. E stands for the electron, V stands for the voltage over here. As you can see, it's equal to 1.6 times by 10 to the minus 19 joules. Yeah, you can accept that as a fact, but I'm going to show you where that actually comes from. So over here, I've got a circuit over here. So we're going to work out where this comes from. The 1eV is equal to 1.6 times by 10 to the minus 19 joules. Right now, I've got a circuit, and as you can see, there's a potential difference around here, and there's 2 plates. Right, so first of all, the long stick is positive over here, yes. The other one is negative over here. Right, okay, so therefore, this makes this terminal, don't forget, all the electrons on this side of the wire are going to be dragged towards it, so they're ripped off that plate, leaving this with a deficiency of electrons, making it positive. And the same in the reverse. So imagine the electrons on this side of the wire, they're going to be repelled away from these electrons and therefore end up over here. Okay, so let's say we were to place an electron. So now we're going to take an electron, and don't forget we're going to place it right now, right in the center. So we can take an electron and place it in the center. What do you think will happen to that electron? So E minus for the symbol for the electron. If we scroll up, let's go read that definition again, very slowly. Look. It is equal to the energy gained by an electron as it moves through a 1 volt potential difference. So let's say we were to apply the 1 volt, so the 1 volt is here, across there, and obviously that's 1 volt across there. So don't forget the voltages is going to be the same, across there and there, over here. How much energy does it gain? How much energy does this electron gain? Well, we know that it will gain energy and it will be attracted across there. So it will gain kinetic energy, so EK will be gained, kinetic energy gained. So we can put that down over here. The kinetic energy gained, so the EK, don't forget kinetic energy gained, must come from somewhere. The energy it gains. How much energy does it gain? Well, that will be equal to what? Where's that energy going to come from? It's going to come from the supply. It's going to come from the supply voltage over here. It must come from over here. So EK gained is equal to the energy from the supply. That's what I always put down. The energy from the supply, just conservation of energy. So how am I going to link the voltage to the energy from the supply? Well, we recognize that voltage is equal to the work done per unit charge. Yes, the voltage is equal to work done per unit charge. So the energy it gains, W, is equal to the voltage times by charge. You could keep it as E, but you could keep it as W, depending on what you want. So we're going to replace the energy from the supply with the V over there and the Q. Good. And the energy obviously is going to be the EK gained. There we go. Yes, okay. Right, now, what was the voltage we applied? Well, look, hopefully you see it's 1 volt, so it'd be going to be 1 volt over here. What was the charge? What is the charge in question? Well, the charge in question is the electron itself. So Q is the charge of the electron charge E, which is going to be equal to 1.6 times by 10 to the minus 19 coulombs. So we can put that into here. So this becomes 1.6 times by 10 to the minus 19, just remove that, 19 coulombs over there. So therefore this becomes 1.6 times by 10 to the minus 19 volt coulomb. Okay, so the energy gained, yes, so the energy gained. Obviously it will be kinetic, so it will be E energy gained, yeah? Same as the kinetic energy gained over here. So now, how are we going to get the joule in here? So how are we going to, we're nearly there right now. We recognize that from this formula over here, we know that a voltage is equal to energy per unit charge. So therefore, looking at the units then, we're going to see that, just draw it over here. So we know that V is equal to W divided by Q. The voltage, therefore, so in terms of the units then, so we can put it in brackets. So 1 volt is equal to joule divided by the coulomb itself over here. So yes, a volt coulomb, moving the C up, volt coulomb is actually equal to a joule. Yes, so the volt coulomb is equal to a joule. It's getting a bit messy actually on this side over here. So the volt coulomb is equal to a joule here. So therefore, we can say that, don't forget this volt coulomb is a joule. There we go, that's a joule. So therefore, we can then finally finish off by saying that the energy that electron gained will be equal to 1.6 times by 10 to the minus 19 joules. And there we go. And that is going to be the definition of 1 electron volt. So that's going to be equal to 1 electron volt, which will give the symbol of 1 electron volt is equal to 1.6 times by 10 to the minus 19 joules over here. Excellent stuff. So hopefully that gives you a better understanding of the electron volt. You don't just memorize that it is 1.6 times by 10 to the minus 19 joules. Make sure you understand the principle of dropping this electron within the 1 volt potential difference. It will gain energy, and that energy will be equal to the energy of the supply. And obviously we can use the voltage is equal to energy divided by charge to obviously prove this formula over here. Easy stuff. Okay, right, so now let's try a couple of bits of calculations and therefore get you familiar with how to use it. So first of all, over here, the simple method is going to be, if I want to go from electron volts to joules, I times by 1.6 times by 10 to the minus 19. Okay, so we times it going that way. And if I was to go from joules to electron volts, I divide by 1.6 times by 10 to the minus 19. So make sure you can understand the conversion. It's pretty easy for this bit over here. And now let's try and do it with a couple of calculations. Okay, so let's say, for example, we give you 10 electron volts. How many joules is that? Well, all you'd simply do is we know that 1 electron volt is equal to 1.6 times by 10 to the minus 19 joules. We can bang that into here, so therefore it becomes over here. So it's going to be 10 times by 1.6 times by 10 to the minus 19 joules over here. So finally then, this will then become, so obviously it's going to be times by 10. Oh, so it's going to be obviously 16 times by 10 to the minus 19 joules, which is the same as 1.6 times by 10 to the minus 18 joules. Yes, make sure you're happy with that. Okay, right, that's one calculation. Let's try the reverse to see if we understand it. 2.176 times by 10 to the minus 18 joules is how many electron volts? Right, how would you do this one? We simply divide it this time. So don't forget, 1 electron volt is equal to 1.6 times by 10 to the minus 19 joules over here. And then from here, we can recognize that we just divide them. So let's do that. So 2.176 times by 10 to the minus 18 divided by 1.6 times by 10 to the minus 19 in this case over here is going to be therefore be 2.176 10 to the minus 18 divided by 1.6 times 10 to the minus 19 in this case, it's equal to 13.6 electron volts. Easy stuff. Okay, so we've come to the end of this lesson, so if you're still struggling, check out the playlist I've put in the description. I've got more stuff related towards this topic, especially make sure you understand that it usually comes up in the topics of quantum, yes, when you're looking at energy of a photon, sometimes in electricity as well. So I'll put the playlist, both of them, they're in the chat over there. Obviously, everyone, if you still like my content, make sure you like and subscribe and give it a thumbs up because it goes a long way with me. And obviously turn on notifications when every time I post a video, then you get notified. Alright, okay, so we'll leave it here for today. Ciao, ciao, goodbye, and good luck.